Okay, students, let's pick up with the last part of this lesson on page 535. At the top of the page, it says vertical motion models. In lesson 9.2, we studied the model for the height of a falling object that is dropped. For an object that is thrown up or down, the model has an extra variable. It's called the initial velocity. So I don't know if you remember this, but from 9.2, we had that if an object is dropped, I mean, this is a physics thing, and this is where you really do see a lot of, you see the use of quadratic equations used to describe motion in physics. Okay, so we learned this model, right, where we had, this is like the initial height, and then this is the resulting height. And when we solved it to see how much time it would take to drop something from a height to get to, maybe the ground or something like that. Now they're going to change it to when an object is thrown. So this is a dropped object. And so thrown, like we're on the ground, we're throwing a ball up in the air, okay, and it's going to go up. It's going to travel up, stop, and then it's going to travel down. And so that's this new equation. H equals negative 16t squared plus vt plus s. Okay, so just wait. They're going to tell us all these different things, what they are. So h, that's the height that the item ends up at. Okay. T, this is going to be time. V is going to be our initial velocity. So, if we're throwing something up, how fast are we throwing it up to begin with? So that's initial velocity. And remember, velocity tells us whether it's going up or down. So if it's going up, it's a positive velocity. If it's falling down, it's a negative velocity. And then S here is going to be our initial height. Okay, so that's still the same as it was before. So initial height. Okay. And that was what this is too. Okay, all right, so let's read example 4. Okay, example 4 says, hot air balloons. You're competing in the field target event at a hot air balloon festival. From a hot air balloon directly over a target, you throw a marker with an initial downward velocity of negative 30 feet per second from a height of 200 feet. How long does it take the marker to reach the target? All right, so what's our, what we're going to do, okay, let me start over here. This thing's going to land on the ground ultimately, and that's really where, so our height, our resulting height is going to be 0, right, because it's going to land on the ground. We get negative 16t squared. Now, what do they say the initial velocity is? They're throwing it downward, so it's negative, and they say negative 30 feet, so it's negative 30t. And then the height that it's starting at is 200 feet. Okay, that's where the hot air balloon is. And they want to know how long it's going to take for, how much time. I got to solve for t, right, to find out how much time it's going to take for that to happen. All right, so here we go. So we're going to say x. Oh, it's not x, it's h now, right? It's height. So h is like height, okay? So we have, it's like y, I'm sorry. So we get 0, okay, equals this. Okay, so we're solving for t. T is like x. So t equals the opposite of b. Oh, here, let's identify a and b. That's negative 16. What's b? Negative 30. And then what's c? 200. We're going to use the quadratic formula, and we're going to solve this, okay? So opposite of b, well, that's going to be positive 30 now, right? Plus or minus square root of b squared, that's negative 30 squared, minus 4 times a, negative 16, times c, which is 200, all over 2 times a, which is negative 16. Okay, so you have to get your calculator out and figure all this stuff out. So t equals 30 plus or minus, you're going to end up with 900 plus, okay, whatever, 800 times 16. I'm not sure what that is. You have to take the calculator out, figure that out, and you're going to crunch some numbers. Okay, and you're going to end up with 13,700 all over. Yeah, and just remember you're multiplying this first. You're going to end up with a plus, so it's going to be 900 plus this. Ends up being 13,000. All 2 times negative times 2 times negative 16, that's negative 32. Okay, and so when you do that, you're going to end up with t equals 30 plus this over 2, and that's going to be roughly, that's going to turn out to be 2.2272 seconds, okay? And then you're going to end up with the time, when you do the minus, the 30 minus this, you're going to end up with the negative time. And so that's roughly, and I guess I should use a little squiggly, it's going to be, it's approximate. It's going to be negative 4.6 seconds. Now, with a quadratic, the algebra for this makes perfect sense, but in the real life situation, negative time doesn't make sense. So what happens is, when we're doing a real life equation, we just toss that negative value out and we don't look at it. We just look at the positive value. Okay, and so that is the answer to this particular question. Okay, so I want you to pause the video now, and I want you to go ahead and do the checkpoint for number 7, and then press play. All right, so if you're pressing play, I'm assuming you've already worked through checkpoint number 7. So here is my checkpoint number 7. All right, so h equals negative 16t squared plus vt plus s. They're telling us that v is equal to negative 60, so I'm putting that into this equation. We still have the initial height of 200, and I'm just using the quadratic formula just like we did before, and I'm putting all of these numbers into their appropriate places here, and I'm crunching all the numbers out, and when I do, I start off with this one. I end up with 60 plus the square root of 16,400 divided by negative 32. When I do, I get x is equal to, and I keep forgetting, approximately negative 5.9 seconds. And again, it doesn't make sense in the initial, in the real life situation. So even though the algebra is correct and the answer is technically correct, we discard it, okay, because it doesn't make sense in real life. So then the second solution is going to be 60 minus all this, and I'm going to end up with a negative over a negative, which is going to give me a positive. So I'll end up with x is approximately 2.12 seconds. So that's the answer I'm going to keep. So it's going to take about 2.12 seconds to reach the ground here, given these conditions that they gave us before, this height and this initial velocity and so forth. All right, so that is the end of section 9.6.